So in this set of videos, we're going to start talking about abstraction. So abstraction is when you define the required functionality for something without actually implementing the details. In other words, we're focusing on what needs to be done, not on the how it's to be done. So interfaces, as you saw, are purely abstract and they don't specify any actual aspect of the implementation. The actual implementation, of course, was left to the classes that implement the interface, and that's why we use the word implements when we're using an interface. And as you can see, I've got the challenge from the interfaces set of videos, and I'm just going to go through and just confirm that again. So you can see that we've got our interface here. Now this was the interface that originally had the array list, and if you remember, I changed it back to a list, and I changed it back to an array list here just to actually talk about this a little bit more. But again, getting back to the interface defines what needs to be done. It doesn't define how it's done. The how, we'd actually have to go into the class, in this case say monster, and that's actually implements. That's implementing the iSavable interface, meaning that it's actually going to do the work. And we're getting that error right now, by the way, because as you remember, we actually changed this to a list, but I've purposely changed the interface back to an array list because I want to talk about that. So the iSavable interface, as you can see on screen, provided or specified that there must be a write method that returned an array list of values to be saved, and also the read method, as you can see on the screen that was provided with an array list of values to be restored. So there weren't any other details of how the class should populate or write the array list. No details on what the class should do with the read values either. That's left entirely up to each individual class. You could, really, if you wanted to, set it up so that each class that implemented this interface might do completely different things with the write and read methods. So there's no rules of what's to be done in those methods in the interface, only that those methods have to be implemented in the particular class. But strictly speaking, if you look at this interface, it's not complete abstraction. And the reason is in this particular case, there's a specification that array lists must be used. But in a type language like Java, it's hard to avoid doing that sometimes. But in this particular case, and I explained this a little bit in the challenge, in the previous challenge, the interface challenge, we can abstract this and use just a list. So what we could have done is we could have changed it, and what we did do was we changed it. So we actually removed the need for an array list and actually just changed it. So in actual fact, it was just a list. And by doing that, we abstracted again because we then didn't force the monster class or the player class or any other class that implemented this interface to have to use an array list. They could use any type of list for that matter. And that can be really useful, and I have made a recommendation that you should do that whenever you're using a list of some type in your programs. Generally speaking, in terms of the declaration, it's good to write it like that, and that leaves your implementation open to actually use any type of list, anything that implements that particular interface, in which case there's the list interface, which is part of Java. And just as a recap, we can see that is, if we actually click on this, I'm holding down Command, I believe it's Alt on your Control, on a Windows machine, click on it, and we can go into the actual list interface, which is part of Java. It's quite interesting actually reading some of the code sometimes, and you can see that this is actually the public interface for the list, or a public interface for list, which the other classes such as an array list within Java, etc., actually have to implement to actually use. Now, obviously, by definition, being an interface is abstract, so you can't use a new iSavable or a new list. What you need to do is instantiate a class that implements the interface, and you obviously saw that in the interface challenge. Now, Java also allows abstract classes. Now, before we get too much into that, I just want to go one step further and just mention that with this interface, we could have actually taken it one step further because we specified the type to be string. But again, if we wanted to be really flexible, we could have even removed that and made that a really generic list and left it up to the user, the class that implemented this interface, to actually decide what type to actually use. I could have quite happily done that, and we could have then gone back to our monster class and actually looked at changing it. We would have had to change a few little things around a little bit in terms of the definitions, but ultimately you could have given that extra functionality or that extra flexibility, I should say, for the actual classes that were implementing this interface. So keep that in mind, that you can take it one step further if you want to go to that level and leave yourself maximum flexibility, but sometimes there's a bit of a fine line as to how generic you make it and how specific. Sometimes somewhere just in the middle might be the way to go. So as I mentioned, interfaces are by definition in Java abstract. So you can't use the new iSavable or a new list. You have to instantiate a class that implements, the interface. And what we're going to do is I'm going to close this one down now. I'm going to swap over because I've created a new project in IntelliJ for our abstraction. We're going to actually start typing some code because, as I mentioned, Java also allows abstract classes. And these are classes that define methods but do not provide an implementation of those methods. The implementation itself is left to the classes that inherit from the abstract class. So this is different from inheriting from an interface. You can also inherit from an actual class as well. So in the videos on inheritance, we created a very basic animal class and then we extended it to create a dog. Let's see whether we can do something similar now using an abstract class. So I'm going to actually open up this now and create a new class, new Java class, and I'm going to call it animal. And what I'm going to do is I'm going to make this an abstract class. So to do that, we type in the word abstract after our modifier. So public abstract class animal. And we can define the variable. So let's type private string name. We can have a constructor, which will pass us the name of the animal. And let's also add a couple of extra abstract methods. And this is the part I want to show you for eating and breathing. So we can put public abstract, again the abstract keyword after the modifier, void eat. And notice we've just put a semicolon there, so we haven't implemented this at all. And public abstract void breathe. And we can also add a constructor. We can also add a getter, I should say, to name. So there's an abstract class. And you can see here what we're doing is as we're about to see, we're going to inherit from this abstract class, and it's going to let us define behaviors that are necessary without specifying how they are to be performed. And this really ensures that the subclasses, such as the dog, must actually implement them. Because, of course, normally in the normal class, if you're extending from a class, you can create a base method in the class, but there's no requirement for the other class, the class that is subclassing, to actually implement those methods. But by creating abstract methods, we actually are forcing the class that is ultimately going to implement from this abstract class to create those methods for us. And that's why we've actually marked them as abstract. So the other methods and the other field in this case are quite okay, and they work as normal Java code, but we're actually specifying and saying there's some abstract methods here that have to be implemented. So if you did actually refer back to the inheritance videos, you'll see that this is very similar to that. Really, the only difference is we've actually marked it as abstract, the actual class definition at the top there, and also we included those abstract methods as well. So to keep things simple in this example, I've actually removed the member variables, brain, weight, etc., just to keep things really simple. Now, if we actually try and extend from this, I want to show you what actually happens. So I'm going to create a new class. I'm going to call it dog. And I'm going to extend animal. And I think I put animal in the wrong place. Animal should have been in our package, so I'm just going to move that, drag it. And it's asking whatever we want to move it to. We want to move it into that package. So I'm going to click on refactor. And that should fix it up now. So we're actually in the right place. But now you can see we've got a different type of error. And if we have a look at that, it's actually telling us that class dog must either be declared abstract or it needs to implement the abstract method eat in animal. In actual fact, there was two methods there it needed to implement, but this little error message is only popping up the first one. So you can see that now in order to be able to create a valid class, we have to implement those methods. So we could do something like we'll create a constructor first for the dog, like so, and we'll just use the default super to save the actual name, which is in the animal class. And we can do some overrides now. So we can do Alt-N and we can actually go to implement or override. They'll both actually pop up the same things. And you can see now we've got two options here. We've got the two options there. And notice the little descriptions here, or the little icons are a little bit different. So get name, you can see that's like a method, but this one's also a method, but notice how it's got a chunk taken out of it. That's IntelliJ's way of telling you that this is an abstract method. So I can actually select both of those and override them, which then makes the class valid. And I can just put something in the code. Get name plus is eating, and for breathe in, breathe out, repeat. Pretty basic. So that's now made it a valid class, as you can see. And obviously keep in mind that because we did implement the getter for the name get name in the animal class, it's available in this class when I've actually used it here in the eat method. And likewise for the constructor, I mentioned that we actually called the constructor using the super keyword, which calls the constructor that's actually in the animal class as well. So the important thing here is that not all methods have to be abstract. This is one of the differences between an abstract class and an interface. You can actually mix these up. An interface, if you recall, if we go back and have a look, actually looks like I closed the project. I probably should have just switched over. But with the previous interface, which you saw earlier in the video, it's the entire interface was completely abstract and there's no implementation whatsoever. So there's no opportunity for us to enter fields. There wasn't any opportunity for us to enter any other code. We purely were able just to specify the methods that were going to be used for that interface that a class that it was implementing that particular interface had to actually fulfill in order to make it valid. But as you can see in the case of animal, we can actually mix it up. We can actually add fields. We can add regular methods, or a constructor in this case, but also a regular method, as you can see there with the constructor. But then we can also specify that certain methods are abstract, as you can see there. So in terms of actually using this, it works now as you would expect. So if you go to write some code, we could do something like dog equals new dog, Yorkie. Dog.breathe, again, behave, you would think it would work, dog.eat. And if you actually run that, breathe in, breathe out, repeat, Yorkie is eating. So you can see that it's all working nicely as you would think that it would be. Okay, so that's working as you think it would, but let's take this now to the next step and actually now create another class, which in this case is going to be bird. New Java class, and we're going to call that bird. And we need to extend, because obviously we're using the extends keyword because it's a class, and animal. And create a constructor with works as you think it would, and let's also override those methods. Eat and breathe again, and we'll put eating, get name plus is pecking, and for breathing, well, that's going to be the same, isn't it? So it's breathe in, breathe out, repeat, like so. And of course we can then go back to our main class, main method, bird equals new bird, parrot, bird.breathe, bird.eat. We can run that. We get the results as you can see. Bird's breathing and parrot is pecking, Yorkie's eating, so it's doing the right thing there. Now birds can also fly, so it could be a good idea to add a fly method to our bird class, but not all birds can fly, so implementing a fly method in the bird class is not a good idea. Better idea would be to create an abstract bird class that extends animal and also has an abstract fly method that individual bird objects can implement as they're able to. So let's go ahead and see how that would work. So we'll go through now and modify our bird class. Close this down to give us a bit of space. Now I'm going to change this up here now where it had public class bird. I'm going to make that abstract. Leave the constructor as it was and also leave the two methods as they were, but also down the bottom, let's add another abstract method. So public abstract void fly. So that's another abstract class at this point. So this is an abstract class that itself is extending from another abstract class. It's implementing the required methods that the animal class requires it to, namely eat and breathe, but it's also defining an abstract method fly that ultimately has to be overridden by another class as well. And of course, we made this class abstract, which it needs to be in order to be able to do this anyway. So now that we've done that, of course, if we go back to the main class, we'll get an error because if you just highlight it, you can see what the error is. So bird is abstract, it cannot be instantiated. Remember we said that earlier in the video that you can't directly instantiate a class that is abstract in any way. So what we need to do is actually create another class. So to do that, we'll change this and we'll actually create a parrot class. Come back here and create a new class, parrot. We're going to extends bird. We'll add a constructor. And all we need to do here is because the other methods are already overridden in the bird class, we only really need to do one. So if we go back there and have a look and go to override, we can still override eat and breathe if we wanted to. If for some reason this type of bird had a different way of eating or breathing, but really all we want to do is override fly in this case to make this class valid. So I'm going to do that, and I'm going to put something like flitting from branch to branch. So it's actually flying effectively from branch to branch. And again, parrot's automatically inheriting eat and breath from breathe, I should say, from bird, so we don't have to re-implement those methods again. That now has its own implementation for fly. So if we go back to the main method now, we'll now change this so this is actually a parrot instead of a bird. Remembering that parrot is now extending from bird. Parrot. And we'll say it's a new parrot. And now instead of typing parrot as a name, we'll say it's an Australian ringneck. And it's going to be parrot.breathe. That will still work. Parrot.eat. But we can also do parrot.fly now. So if we run that, you can see that there's no errors anymore. We can see now Australian ringnet is pecking, flitting from branch to branch. And just as another example, to show that we could do something different, let's create one more class, a new Java class, and we'll call this one Penguin. And we're going to do extend from bird again, extends from bird, create the constructor, and let's just override fly again. And we could put, I'm not very good at that. Can I go for a swim instead? And that's our implementation of Penguin. So going back to the main method again, we could just come down here. We could put Penguin equals new Penguin Emperor, and Penguin.fly. And now if we actually run that, you can see we actually get the message quite correctly still that in the case of the bird, Australian ringnet is pecking, flitting from branch to branch, and we only printed out the fly method for penguin. I'm not very good at that. Can I go for a swim instead? So you can see that's working quite nicely. So I'm going to end this video here. In the next video, what we're going to do is start talking about how this is different to an interface and how you decide whether to use an interface or an abstract class. So I'll see you in that next video.